Good Thursday evening, everybody. All eyes are on Hurricane Dorian as it starts to make its approach towards the Bahamas and eventually the southeast United States coastline. I do know that a lot of us have a lot of plans for the Labor Day holiday as we approach that, and the last thing we all want is a hurricane to throw a wrench in all of these plans. But unfortunately, that's what we have to deal with. So this video, I'm gonna talk about some thoughts that I have about this storm, and we're gonna look at the official forecast track and kind of see what the potential impacts could be with this storm. The first thing I want to mention is that this is a small system, which makes the forecast track and intensity all the more difficult. The reason why is a very small system can intensify very quickly. It can also weaken very quickly, and any type of wobble that it makes all the difference in terms of where the potential center will make landfall. And because of the small systems, how small it is, the strongest winds are in a very, very, very tight place right near the center. So that's why it's very important in this case where that center of circulation goes, but that's why the cone of uncertainty is rather large this far out in advance, is because any wobble and how small it is, it's very hard for some of our models to kind of get a grasp on this kind of scale of a system. We'll talk about that in just a second. But overall, the satellite imagery showing an intensifying hurricane. As of this recording, the latest reconnaissance aircraft is finding a hurricane very close to Category 2 strength, if not already there. So it has intensified late this afternoon and going into this evening. Earlier this morning, we had some effects of some southwesterly shear that brought in some dry air as well into the core, kind of kept it steady. The morning reconnaissance aircraft planes didn't find any strengthening at all. It was very steady in terms of pressure and winds, and now it is strengthening. So it looks like it's starting to kind of go into that moist environment, tap into that warmer water and the moist air and filtering out some of that dry air. So it is on its way to becoming a major hurricane, which certainly seems very likely at this particular juncture. Looking at the official forecast track as of 5 p.m. Eastern Time, the next track change will be 11 o'clock Eastern Time on this Thursday. Again, we'll likely see another update at 5 a.m. and again 11 a.m. This far out, before landfall, the track updates are at 5 a.m. and p.m. and 11 a.m. and p.m. Intermediate advisories usually change the maximum wind speed and also a little bit of a location change, but it does not change the forecast track until the storm starts to get closer to land impacts, which will likely not be till later this weekend. So for now, if you're wanting a track change, just keep that in mind, that those are always updated officially at 5 a.m. and p.m. and 11 a.m. and p.m. Eastern Time. Looking at the track, though, we're looking at a major hurricane very shortly. Again, it's already pretty much a Cat 2 as we're talking right now. So it'll likely be a major hurricane sometime tomorrow, especially over the weekend. Very likely that it will happen. And we're going to start to see that bend back towards the west as we go starting tomorrow. So it is coming up very shortly, which I will show in just a second. And then as we get to the weekend, it gets very tricky. You see the large cone of uncertainty, which I mentioned just a little bit ago, how large it is. Again, the core of this system is literally the size of these icons. That's how small the core of the system is currently. And it won't get too much bigger. I'll talk about that as well. But overall, it's about the size of these icons. So the cone is very large because, like I said, with small core systems, they can wobble a lot within this area. And because it's so small, where exactly the center deviates makes a lot of a difference in terms of who sees the worst impacts along the east coast of Florida as it makes its approach. So that's what we're looking at. No watches and warnings are currently in place. That usually happens around 48, maybe 54 hours out in advance, usually about 48 hours, which is 2 days in advance when you start to get to see those watch and warnings start to go in place for the land areas. And we are not in that time frame yet. Now, once we get tomorrow night, that's a little bit of a different story, especially for parts of the Bahamas. Let's take a look at the models. I'm going to fast forward just to save a little bit of time here, and we're looking at tropicaltidbits.com. Again, a big shout out to Levi Cowan. Great job on the website, and thank you for letting everything be public. Love it. All right, so we're looking at the American model here. Usually we look at two main models when it comes to forecasting. the GFS model, which is the American version, and then you have the European model, which tends to perform a lot better. It's also important to keep in mind that no one model is ever perfect, nor should you always look at any one model all the time. But in this case, we're going to look at both of them, and the European usually is the more reliable, so we'll keep that in mind. Fast forwarding to tomorrow night, I think it's going to be a pivotal point in the forecast for Dorian. Looking at the American model, has a major hurricane east of the Bahamas and north of the southeast Bahamas, sometime late tomorrow night into Saturday morning. The European model seems to agree with this very well and has a major hurricane there as well. When it comes to these global models, it's important to keep in mind that they are low resolution. Therefore, they don't really have that much high grid spacing, which is what you want for higher resolution to kind of catch the smaller cores of these systems. The smaller the systems are, it's a little bit harder for some of these global models to pick up the exact intensity with these systems. So just something to keep in mind. But overall, even with that, we've seen it a number of times with these small core systems, regardless of the fact that these global models, including the European, struggle with exact intensity. They usually tend to grasp the upper level pattern very well about 4 days in advance, which is where we're at. So we're going to go over that here. And looking at the European, we're going to switch over to the upper level pattern because it's going to be a big key in terms of the exact track of Dorian. So as we go into early Saturday morning, notice on the European we have this nose of high pressure, and with that kind of flow, that usually forces these storms back towards the west. So you can kind of see that trend, a turn back towards the west. As of Thursday afternoon, this is when things get really complicated, something that we didn't want to see, nor were we all expecting this afternoon for this much of a change. The European came in much slower. The reason for this is you will notice that this ridge of high pressure is still nosed here. You'll notice by the colors, but if we look at the previous runs, notice how this ridge of high pressure, you notice how sometimes it tends to be just a tad bit weaker. So usually when you see a ridge of high pressure, that means when it weakens, it means this system is starting to turn back towards the north. In this case, it's not so fast. The reason for this, looking at some of the data this afternoon, I had to kind of look a little bit deeper into some of the data. There's not a trough. Usually what you want to see is a trough to kind of dig down a little bit here, open up a weakness, and make it that much easier for these storms to follow it and push up towards the north. In this case, due to this time of year, the trough is way up here, up in Canada, and it's very, very weak steering flow in this area. With that being said, since there's no real trough, there's no real weakness to the north side of Dorian, what happens is it's still being steered by this ridge of high pressure in the upper levels, but the overall wind flow, the wind speed coming around this ridge of high pressure weakens. So what happens is this storm starts to continue moving west underneath this ridge of high pressure, but slower, not as fast as the wind flow starts to break down. That's what I've been looking at in terms of the data today, is the European has been a lot slower for that exact reason. It basically says that this trough has a little bit of an effect, but not enough to where it's still being steered enough by this ridge of high pressure nosing its way in the Western Atlantic. So very interesting stuff there being depicted by the European. The GFS, on the other hand, is a lot faster when it comes to moving Dorian towards the west. You notice by Sunday, it's over here by the northern Bahamas, and the European is way back in here on Sunday. So it's going to make a huge difference in terms of landfall time, impacts, potential size of the system. There's so many question marks that are still going into this forecast. That's why it makes it extremely difficult to say, okay, this is where it's going to make landfall. It's just impossible right now to kind of say where exactly it's going to make landfall. And that's why with these small core systems, you still have such a large cone this far in advance, because it matters. Where does this core come on shore? So we're going to have to continue to monitor this over the next few days very closely. But overall, the American model is faster. But if we look at the past few runs, you will notice that the American model has been trending a little bit further south and towards the east, slower and further south. So a little bit closer to the more reliable European model. So a very interesting trend. The reason why I see this happening is looking at some of the data earlier. So if I fast forward, I'm going to go back to the previous run this afternoon. And what I'm going to do is I'm going to turn on the lower level flow. And you notice the low level flow is a little bit stronger and more east to west. So something is telling me that the American model thinks that Dorian is very shallow because of how small it is. And it thinks that it's being affected more by the low to mid-level flow, which, yes, would be stronger and more east to west oriented, which means it would move faster and move more due west towards the coast of Florida in a faster time frame. That's what it looks like to me. Because looking at the upper level pattern, as we mentioned before, very light steering flow. You kind of got a upper level low over here to its west, and you kind of got a little bit of an upper level disturbance to its north. Overall, it's still a very weak steering flow. And overall, you still kind of got this ridge of high pressure just to its north. So you got this ridge of high pressure to its north acting as a wall. You get an upper level low kind of opening up kind of a path like so ahead of Dorian. So everything is still slowly, I'll put that in quotes, slowly pushing it off towards the west and even southwest. So the latest runs of the GFS have been showing a stronger Hurricane Dorian and kind of pushes parts of the core of the storm into the upper levels. So it starts to be steered more by the upper levels than the lower levels. Upper levels are slower, a little bit more west and southwest. Lower levels are faster and more westerly to even just slightly north of due west. So those are the difference that I've been noticing between the two models this afternoon, and as to why the GFS is literally 2 days faster than the European model when it comes to landfall, which is a pretty big deal. So just something to keep in mind. I'm going to look at the upper level current steering, and we can see here is Dorian. We're looking at the upper levels, parts of the atmosphere, because I do think that'll end up being the steering flow. And we can already see that the overall flow is like this. So here's that wall right in here that Dorian is about to run into. That is your ridge of high pressure sitting right here just to the north of Dorian. So yes, Dorian is moving in this direction for now, but literally in about the next 12 hours from this recording, it's going to run into this wall and it's going to be forced back to the west. So we can already see the ingredients coming into play for the first turn. That's very critical. You have the winds like this ahead of it with the front that's currently over the eastern U.S., but you have the flow like this. So right in here, you have your ridge of high pressure sitting just to the north of Dorian. That's looking at the upper levels. Looking at the lower levels, it's kind of like this. We're looking at a wind flow like such. So that's why we're seeing Dorian get caught up in this flow and moving in this general direction. It's feeling a little bit more of that lower level flow. So again, very critical as to which level of the atmosphere the storm is going to be steered by over the coming days. You can see the steering flow even more so. Here's that ridge of high pressure, and eventually we're going to start to see that turn back towards the west. So a lot of the steering flow is coming into play. It's about to turn back towards the west. The question is, how quick does it start to feel the effects of the upper levels instead of the lower levels? It's still moving at a fairly decent clip right now. Still moving at a decent clip, generally in this direction. But when it starts to turn back towards the west, how quick is it to slow down versus going at the same pace it's doing right now? Very critical in terms of landfall time, strength. There's a lot of question marks that are involved with whether or not this slows down. Because notice here, if it doesn't slow down, most of the models that don't slow it down are in agreement that sometime Monday morning into Monday afternoon would be when Dorian would come close to being on shore. If it slows down, it could be a day or even 2 days, believe it or not, later than this, and possibly further south. So again, a lot of repercussions in terms of how fast it's going to move. Even more so, that means that anyone along the coastline, I'm going to say from the Carolinas all the way down to South Florida, should be monitoring it. This does not mean you panic. This does not mean you start evacuating and rushing out of town. This is not what that means when you're inside this cone of uncertainty. It means you're prepared, you have the supplies in case. It doesn't hurt to have the supplies, and then you vigilantly watch this system. You watch for wobbles. You have everything in your mind. You understand that this could wobble back to the north, that this could wobble back to the south. You keep that in mind. You're prepared, you're vigilant, but you don't panic. That's the big thing to take away from here, is if you have your supplies in this general area, great, awesome. That's what you want to do. But now you watch, now you wait. You have time. You have time to wait and watch to see what this is going to do, to see what what your next course of action is going to be. Because remember, it's a small system, and if it stays this small, if it comes in further north, I'm serious, parts of Southwest Florida won't see much at all from this system if it comes in further north, because it's that small. This is not a size of an Irma. This is not 500 miles wide. This is not a size of a Francis. This is not a large hurricane, folks. This is a pretty small one. Now, if it were to stall or move slowly in the Bahamas, that could change a little bit. I still don't think it's going to be that large, but it could be larger than how small it is now. So just something to keep in mind. The faster it moves and the smaller it is, the further north it goes, you start to see that southern and western edge start to really, the effects are not that large right now in the south and western part of this storm. Everything is going to be heavily weighted on the north and eastern side of this storm. So that's why the further south this goes, we start to have a little bit more concern for a larger population, a larger area to be impacted by it. So something to keep in mind. And also, I do want to point this out. I'm not saying it's going to happen, but I am saying that unlike yesterday, a sharp turn just before the coastline is not off the table. It's actually back on the table as a possible scenario. So again, I'm not saying that's the most likely. This, by the Hurricane Center, actually, in my opinion, is one of the more likely solutions. But it curving before land is also on the table and probably going to be the most hoped for by many, I am sure, along the Florida Peninsula. So, like I said, small storm, moving pretty fast right now, going to slow down. The question is, how much does it slow down? And that will affect its turn in the long run. It's going to make a turn. The question is it going to be here? Is it going to be here? Or is it even going to be here by the time it starts to make that turn towards the northwest? All of those are going to be critical over the coming days. So I know I don't have a whole lot of answers for you, but basically what I have to say is, if you're being prepared right now, getting your supplies, you're doing what you need to do. Now you kind of watch, you keep everything in the back of your head, you're smart, you kind of listen to the reliable sources when it comes to weather information, and we'll nail it down over the next few days, folks. We're keeping you safe and informed. That's what we want to do. We don't want you to panic, freak out, and give you false information. So just keep it tuned. I'll try to have updates as I can over the next several days. Until then, you definitely want to keep it tuned to the National Hurricane Center for the official forecast track and your local National Weather Service offices for any upcoming short updates.